Hi guys, so this is a new video in the series on tangents and normals under Math SL differentiation. In this video I shall focus on problems that require us to find the equations of tangents and normals. I shall solve the 4 questions right there and I shall begin question 1 shortly. So question 1 came in paper 1, May 2012, time zone 1, question number 3. Kindly take a minute, pause the video, attempt to solve, and my explanation shall follow shortly. So in question A, we are given that f of x equals e to the power of 6x, and we are required to find f dash. This is a simple chain rule problem. You can refer to previous videos that tackle chain rule questions if you want elaboration, but for the purpose of this video, our final answer is 6e to the power of 6x. In question B, you are told that the tangent to the graph of f at the point P 0, B has gradient m, and you are required in I to show that m equals 6. So let's rewrite our expression for m in our usual terms. So in order to show that m equals 6, I'm basically trying to find the slope of the tangent at point P, which is the slope of the tangent at the point where x equals 0. And I got this from this piece of information right there. So the slope of the tangent at x equals 0 is found by simply finding f dash of 0, which in itself is found by plugging 0 for x in the green equation. So I get 6e to the power of 0, which is 6. Next, I'm required to find b, and b is the value of y that corresponds to the x value of 0. So when x equals 0, y equals b. Hence, f of 0 equals b. So y when x equals 0 is written as f of 0. So f of 0 is found by simply plugging 0 in the black equation, the original equation of f of x, and I get e to the power of 0, which is 1. Now I need to find the equation of the tangent in question C. I can write down the formula for the equation for you to remember. So the formula is y minus y1 equals m times x minus x1, where m is the slope and x1 and y1 are the coordinates of the given point. So y minus 1, and I got this one from the y coordinate of P, equals to 6, and I got the 6 from the slope, times x minus 0, and I got the 0 from the x coordinate of P. So y minus 1 equals 6 times x minus 0. You can actually stop right there because they did not request a specific format for the equation of the line, like y equals mx plus b, for example. But since this one is very simple, we can simplify. We can say y minus 1 equals 6x, and then move the 1 to the other side and get y equals 6x plus 1. And this concludes our first question. Pause the video to write this down if you will, and I shall begin question 2 shortly. So question 2 came in paper 1, November 2007, question number 8. Kindly take a minute, pause the video, attempt to solve, and my answer shall follow through shortly. So you are required to find the equation of the normal given the equation of the function and a point where x equals 1. So I want the equation of the normal, and this should click in my mind with getting, of course, the slope of the normal, because like we said, to get the equation of any line I need the slope and the point. So I need to get the slope of the normal. So if I want to get the slope of the normal, mn, then I need to get first the slope of the tangent, mt, and then flip and switch. And in order to get the slope of the tangent, obviously I'm going to have to differentiate. So actually what we're going to do is follow this chain but in reverse order. I'm going to differentiate, then find the slope of the tangent, use it to find the slope of the normal, and then use that to get the equation of the normal. So I start by differentiating. Of course, this is very simple differentiation. Next, I want to find the slope of the tangent, and let's rewrite that in the format that we are used to. So to get the tangent where x equals 1, I basically need to find m of tangent at x equals 1, which requires that I find f dash of 1. Differentiate and then set x to 1. Since we've already differentiated, all that remains to do is remove x in the purple equation and put 1. And this gives me 12 plus 2, which is 14. After getting the slope of the tangent found in green, I need to use that to find the slope of the normal simply by flipping and switching. You can refer to previous videos to understand why we do that. So by switching, I mean I go from positive to negative or negative to positive. By flipping, I mean I go from numerator to denominator or vice versa. So since this mt is positive and in the numerator, the mn is going to be negative and in the denominator. So negative 1 over 14. This concludes the step of getting the slope of the normal. Next, I use that to find the equation of the normal, and as we said, we need the slope and a point. So I'm halfway through, I've already got my slope. I need a point that belongs to this normal. So what point do I have? I have the given point where x equals 1. So I need to get the y value that corresponds to x equals 1, so that I have a value of x and a value of y that I can plug into my equation. So in order to get the y value, I simply plug the x value into the equation of the function. So I'm getting f of 1 here. So I plug x, I remove x and I plug 1, so I get 4 times 1 cubed plus 2 times 1, which gives me 6. So the y value that corresponds to x equals 1 is 6. So basically I have a slope of negative 1 over 14 and a point 1, 6. I plug those into the formula of the straight line, which is y minus y1 equals m times x minus x1. So y minus y1, which is 6, y minus 6 equals m right there times x minus x1. As we said before, we can stop right there. We do not have to find the equation in the format y equals mx plus c, because they did not require that of us. In following questions, they are going to require us to find the equation of the normal in the format y equals mx plus c or y equals mx plus b. In that case, I need to further simplify, but for the purpose of this problem, I'm actually done. So take a minute to copy this down if you will. I shall begin question 3 shortly. So question 3 came in paper 1, May 99, question number 4. Kindly take a minute to pause the video, attempt to solve, and my answer shall follow through shortly. So this question is almost exactly the same as the previous one, and we shall follow the same logic. I want to find the equation of the normal to the curve, so I need to find the slope of the normal. So first I need to find the slope of the tangent, so I have to begin by differentiating. So take a look at the answer. So we begin by differentiating this function to get the green function right there, y dash equals 3x squared. Next, I want to find the slope of the tangent at the point where x equals 1. So I want the slope of the tangent at x equals 1, which is f dash of 1. So f dash and y dash are the same thing, of course, so I just have to plug 1 into the green equation right there. So I get 3 times 1 squared, which is 3. Next, given the slope of the tangent, I want to find the slope of the normal, and I do that by flipping and switching. So I switched the sign from positive to negative, and I flipped the number from numerator to denominator. This is the slope of my normal. I have the slope, and I already had the point. It was given in the question. So I have all what I need. I just plug into the formula of the equation of a line, and y1 is the y coordinate, which is 2, so I wrote 2. M is the slope, which is negative 1 over 3, so that's what I wrote here. And x1 is the x coordinate, so that's what I wrote right there. And this concludes the third question in this video. Pause if you'd like to write this down, and I shall begin question 4 shortly. So the fourth question in this video came in paper 1, November 2013. Question number 6. Kindly take a minute to pause the video, attempt to solve, and my answer shall follow through shortly. So this is very similar to the previous problems. We are given the equation of the function, and we are given a point. We are required to find the equation of L, which is the tangent to the curve. So instead of finding the equation of the normal, I'm just going to find the equation of the tangent, which means I don't have to do the step where I flip and switch the slope to convert from mt to mn. I'm just going to use mt as it is. So take a look at the answer. So I begin by differentiating this function to get the green function f dash, which is equal to 2e to the power of 2x. Next, I need to find the slope at the given point. So I need to find the slope of the tangent at the point where x equals 1. And this is found by evaluating f dash of 1. To get f dash of 1, to evaluate this value, I simply remove x in f dash of x and put 1. So 2e to the power of 2 times 1 is 2e squared. And this is my slope. It's of course necessary here that you leave this in exact form, because you do not have a calculator, so you can't really find a decimal value for the slope, and it's actually better to leave it this way. Now that I have the slope and the point, I need to find the equation of the line. But bear in mind that in this problem we are instructed to find the equation in the form y equals ax plus b, or which is better known as y equals mx plus b. So I follow the same sequence of steps. I use y minus y1 equals mx minus x1. You should be familiar with that by now. Next, I simplify. So y minus e squared remains as it is, and 2e squared, which is the slope, multiplies the x and multiplies the 1 to get 2e squared in both. So I have this expression in red. Now I should be aware that e squared and 2e squared are the same thing. So I can actually add or subtract them if I would like to do so, and that's what I'm going to do. I shall transfer the e squared to the other side, and then I'm going to add these two expressions together to get negative e squared. So this is pretty much the same as the previous problems, except that it requires some algebraic manipulation of e squared. This concludes our video. Pause to write this down if you will, and I hope you have found this useful.